In this video, we will talk about optimization. Optimization is finding the minimum or maximum value. Given a quadratic equation, y is equal to ax squared plus bx plus c, when a, the leading coefficient, is greater than 0, it's concaved up. When the graph is concaved up, think of this in a Cartesian coordinate. Y value is the smallest at the axis of symmetry. Axis of symmetry, x is equal to negative b over 2a. Once we have the x value of the vertex, we can simply plug it back into a function to find the value of y. It's the same idea when the graph is concaved down. In the Cartesian coordinate, we have a maximum value when the graph is concaved down. The x value of that vertex is the same as the axis of symmetry. X equals to negative b over 2a. Once we have this value, we simply plug it back into the function to find the value of y. In optimization, we are really interested in finding the value of y. The y value is the optimized value. Does it have a maximum or a minimum? We have y is equal to x squared plus x minus 3. The leading coefficient on this equation is 1, so we have a is greater than 0, therefore it's concaved up. In that case, we have a minimum value. The axis of symmetry is a x-coordinate of the minimum. So axis of symmetry, that's x equals to negative b over 2a. In our case, b is 1, so we have negative 1 over 2. Plugging back into the equation, we can find the value of y. Y is equal to negative half squared, that's 1 over 4, minus half minus 3. Finding the common denominator, we have 4, 1 minus 2 minus 12. So y is equal to negative 13 over 4. So the minimum value of y is negative 13 over 4, and it happens when x is equal to negative half. Now let's look at the question on the right side. Let's rewrite this. So we have y is equal to negative 2x squared plus 3x plus 3. Since a value is less than 0, it will be concaved down, so we will have a maximum value. Again, with the axis of symmetry, negative b over 2a, negative b, so that's negative 3, over 2 times a, that's 2 times negative 2, negative 4. So x is equal to 3 over 4. Now plug in the x into the equation. We have y is equal to, let's do this on a side note, we have negative 2 times 3 over 4 squared. That's negative 2 times 9 over 16. So cross out, we have 1, 8, so that's going to be negative 9 over 8. 3 times x, that's 9 over 4 plus 3. The common denominator is 8, so we have negative 9 plus 18, and then plus 24. So negative 9 plus 18, that's positive 9. 9 plus 24 is 33. So we have 33 over 8. So the maximum value of y is 33/8 when x is equal to 3/4. A gardener has 40 meters of fencing to enclose a rectangular garden plot, where one side is an existing brick wall, so he doesn't need a fence there. Suppose the two new equal sides are x meters long. Show that the area enclosed is given by a is equal to x times 40 minus 2x meters squared. If this side is x, then we know this side also be x. Since we don't need a fence on the brick wall, the remaining will be 40 minus 2x. Area of the rectangle is equal to length times width. So length times width, here is the area of the garden plot. For the second question, find the dimensions of the garden of maximum area. In order to do so, let's distribute this. So we have 40x minus 2x squared. As you can guess already, our a is less than 0, so it's concaved down. Where the axis of symmetry is, that's the x value of the vertex. So let's find the vertex first. Negative b over 2a. So b is 40, so negative b over 2a. That would be negative 4. So x will be at 10. So when x is equal to 10, the width of this figure will be 40 minus 2 times 10, so that's going to be 20. So 20 by 10 meters will be the dimensions of the garden to maximize the area. If we plugged in the value of 10 onto this equation, we will get the maximized area, the biggest area that you can get from such dimensions.